Competitive world, right? Since if you have a model right now in this in the market of OpenAI, and soon we can have another model from other company which replaces the capacity, performance, and efficiency of this model. So this is gonna be evolving, but we need to know how it is being developed, right? So that's our duty to make sure, right? So let me share my screen. Let's start with the session, and we're gonna dive into some of the use cases what I've developed. I'm also working with some cases, and I want to give you the next steps. What I'm right now working on it, and the next steps might be your, I'm gonna be an exclusive session to you guys as well. If it is gonna be an if the people call me, and the oral is right, we're gonna have another YouTube recording or stuff like that. I'm gonna post it in my YouTube channel where you can just have a look and try it with your LLMs what you have it in your cases, right? So let's start, and I'm just sharing my screen. Uh, okay, let me share. Just give me, yeah. Okay, if I'm not wrong, my screen is visible, right? And I'm just what may say, just cutting down my video as of now to make sure to have a full-fledged concentration on the slides what I create. Right. So, yep. Let's start and to be more precise, when or I say when Mona reached out to me and talking about we have a lot of students, both those who are certified in AI or certifications in we're gonna say as intelligence in terms of like people having started to take about their foundation certifications in AI, right? So I was very happy with that thing. Why? Because students out of there in more sophisticated in AWS Cloud Club St. Joseph's, people started to know about the next phase of the career and next phase of the technology, how it is gonna be, and we're gonna start preparing on those things. But I'm not sure how AICF is covered, right? Why? Because but like why? Because if I want to be more precise, so whether they have covered the technical stuffs like more deeper into how it has been evolved or what are the different terminologies and maybe the new ones from AWS would not be introduced, right? So we're gonna dive. We not really gonna deep dive into everything what we have, but we're gonna deep dive into some of the things, right? Which is out of the box with the conceptual terms, and we're gonna make use of it. How we can able to use in our let me say in our practical use cases. How we gonna develop. Right? So that's gonna be the motto of the session. So what do you need to know more from AICF? So a little bit about me, and as you guys know, I work at Logitech and as a data scientist. I work at data science and AI for businesses, and I more focus on global operations. I work closely with global supply chain and other people who are included with sourcing, planning, procurement, etc. I'm not a person who works with works trying to solve the problem to which they are facing right now and focusing on other business cases as well. So other stuffs rather than my profile, a working profile, I'm also an AWS community builder in machine learning category, and I'm also what can I say previously as an AWS Cloud captain. You guys might know, right? Before Mona and Diana, Jivita was there, and before Jivita, I was the one who started this, and I just gave my guns back to Jivita, and Jivita gave two guns, one to Diana and one to Mona. So I'm so excited and so proud to see that the legacy what I've started is still being more proactive in terms of all the other cloud clubs globally, and handling sessions and participating in events and stuff like that. So as I see, right, people who are low students are more involved, more technically rather than more even oriented, and I'm happy to see that as well. And my contributions, right? So I've written a book, right? So that's the major book about the generative transformers and text generation model. So that's the chapter I've written. So where from history to production, where you guys can learn about how transformers, right? One of the important, I could able to say a pandemic to generative AI technology. So and what's how the text generation models has been evolved? Why? Because you just guys just know there are a lot of foundation models available in Amazon Bedrock, but you guys do not know how they are being evolved, right? So taking back to the history, how traditional machine learning was there, focusing from traditional machine learning to neural networks, from simple feed-forward neural networks to convolutional neural networks. Then we moved into recurrent neural networks, and then we moved to sequence to sequence and rec to rec models, and then moving up to transformers. And now we have different types of models in terms of AGI work, where we classify them into three different subcategories called as encoder only, decoder only, and encoder decoder foundational models. So I've included all those in the book, and maybe I can give you the link of the chapter. You can just have a look at the chapter, and you can also read about it. So on next phase, I also work with the additive manufacturing, so which is in the new frontiers and applications of machine learning tools in additive manufacturing as well. So that's one of the other book, one of the other chapter I would have written, where this focuses on the other side, right? It doesn't involve a lot of technical areas, but because it is other way, and it's a cross-functional business transformation because of it, and where the AI and machine learning how can help the additive manufacturing and 3D printing process. So my interest, as I said, I work with problems with cross-business areas and walking through AWS services, and with some of the architectural patterns and how they have been orchestrated to the personal use cases or to the business use cases. What you're gonna work on it. So, right, let's get into it. Yes. So, generative AI, right? Why? Because you might guys heard a lot about it. People are talking a lot about this word, a mnemonic word, I would have to say, Gen AI, Gen AI, Gen AI, Gen AI. But as a person, if you want to pursue a career in machine learning or AI engineer or data science or anything else which is related to AI, right? You guys want to be more precise that you also have enhanced working with generative AI technology. Why I'm saying this is nothing but, right? You can take me as an example, as a valid example, right? But because when I started my career in Logitech, I was just working. My role was very simple, where we want supposed to work with traditional machine learning models to solve some business use cases. But when these things has been evolved and the company started to use, say, like, let's transform our businesses so that our KPIs can be more successful with the help of the Gen AI technologies. Then, but because before that also exposed to the I can say concepts and technologies behind generative AI. But That's the way I started working with Gen AI to solve some of the business use cases and more sophisticated, not in the same business area, but the cross-functional area. So talking more into this, right? So you might see I have put a lot of words here as a grid, or not in a grid, a very things. So we're gonna talk on each and everything. If I'm not wrong, yes, we're gonna talk on each and everything. So let's start with this thing. So first and foremost, right now, if someone talks about AI, people just put their mind to generative AI, right? Because the paradigm to generative AI was machine learning and deep learning, and more sophisticated. Yes, it should be natural language processing as well. But I don't know that people knows about how generative AI has been formed, right? Why? Because what type of learning is being used in generative AI? Why? Because if you guys might know, and you was also cleared your AI certification, so machine learning has three different types of learning, where supervised, unsupervised, and you can also have a reinforcement learning where you can do, right. But in terms of deep learning, if we go, it would draws a lot of neurons, right, and where you're going to talk about where how the neurons can be connected with each other, and that neuron connection maybe may have make the data to more interrelated with each and every other, so that the features can be correlated easily with the output features what we're going to predict or classify, depends on the problem what we're going to solve, right? So this is gonna be the best case, right? What you guys might know. So talking about, right, when I started with the traditional machine learning models, right? So you guys have these two things in your mind. So how the data is gonna be? Whether we're gonna have two different types of data. One is gonna be the data which is being labeled, and other one the data which is being unlabeled, right? We don't have any labels in the data. If I'm not wrong, right, and what may say, if I'm very much clear on those things, you guys might be aware about what type of algorithms will work for labeled data and what type of algorithms will work for unlabeled data. Right? You guys might be aware of it. So very much clear into that. And talking about that, we'll see those things in our next consecutive slides. And what we do, we take the label data, put it into our ML models, right? We have not a lot of ML models where depends on the use cases what you're going to work. Either it's going to be a classification or a regression or clustering or principal component analysis or any other kind of use cases. You just put your data into it and then trying to make the data to get understood. Right. So how it works in this case, right? So when you put the data inside the machine learning model, and that machine learning model tries to understand how the data is being correlated with each other, with the input features and the output features, how it is being priced. And then you'll be deploying this model for any kind of production use cases. So this is how the hierarchy of the traditional machine learning models are. But when you get into Gen AI, right, how these is going to be working. So what do you need to know in terms of data, in terms of Gen AI? So that's a very important thing, right? So first we talked about this. You want to know about the label data. You want to know about the unlabeled data, where what I say in terms of label data, you need to have the classes where the classes depicts that this type of data is belongs to this class. This type of data belongs to this class. So we don't have the labels into it, right? Only if we have the labels, we could able to clearly identify what type of task we can able to perform. So with that label data, we do have the first type of learning, which is called as supervised learning, where we can perform the classification and regression. And you guys might know about what classification and regression problems and what type of algorithms will work for classification and regression. Then moving on from labeled data to an unlabeled data. Right? So when you're moving from labeled data to unlabeled data, you don't have any kind of, you might have a pattern into it, but you can't able to find through with the help of the labels. Why? Because we don't have find any kind of labels into it. So how we can able to do? Let's deep dive into the unlabeled data, and we could able to find the input features are being correlated with each and everything. And then the new learning came, which is called as unsupervised learning, where with the help of unsupervised learning, we depict a lot of use cases, which is example as PCA, which is principal component analysis, clustering, and more. So you could able to see with the type of data which is being available into the market, which is available to us, we more sophisticated, divided the level of learning into two different types. One is supervised, another one is unsupervised. Then what happens? So we want the data to be understood by how we understood the data. So like how a human brain would understand the data, like putting the data into our brain so that the neurons inside the data may be integrated with each and every one to understand the data much more in a better way. So what we did, instead of trying a traditional machine learning model, then we deep dive into a deep learning model where we connected all those each and every features into a neurons. And we had lot of layers of neurons to predict or to classify or to cluster or to, what can I say, to find only the central region of the data. This is somewhat in terms of traditional machine learning. But when it comes to generative AI, right, what type of data you need in terms of generative AI? So any guesses? Right, I just want to put a poll to the participants over here, right? So do you know what type of data or what type of learning is more focused for developing a generative AI model? Let me just look back so that I can get some comments. Yeah, anyone knows, or just give a guess so that does also helps, right? Hey guys, can you hear me? Hello. Okay, deep learning, RAG, not much. Yes, we need a deep learning in terms of developing a generative AI model, but RAG is somewhat a technique, so I just don't want to include that inside here. But I'm just asking about what type of data. So LLMs, LLM is a large language model, right? It isn't. It is a model. It's not. I'm just. I think so. My question is not so clear here. So my question is, right? For machine learning, or for deep learning, we talked about labeled data and unlabeled data, where labeled and unlabeled has been more sophisticated to perform a supervised learning task as well as unsupervised learning task. For the same thing, take a generative AI model. So for developing a generative AI model, what type of data is needed for developing it? Any guesses? Raw data. What type of raw data you needed? So even, right, even labeled data and unlabeled data is also raw data. Sorry, not text. I'm just asking more technical into it. So it's not text. Okay, so let me get back to the presentation so that I can just give you an overview of it. Right. Yes. So hope you guys can able to see my screen, right? If I'm not wrong. Hello.
Yes, we can see
Yes,
you.
we can see your
Sure.
screen.
Yeah. Okay. Thank you. Thank you so much. So that's his right. Let me say the very important stuff where you guys want to know, right? So that is the semi-supervised learning data, right? So before going to attention is all you need, right? I would just want to talk about the semi-supervised learning, right? So you guys know know a lot about supervised learning, and you guys know a lot about unsupervised learning, and you guys also know about reinforcement learning. Why? Because supervised learning learns from the labeled data. Unsupervised learning learns from an unlabeled data. And reinforcement learning learns with the data which is available in the environment so that the training, post-training, as well as all those training happens on the actionable things which is happening inside the environment. So that are the three different cases to be precise in one very short word, one very short sentence. But what is semi-supervised? Take an example. So when you're creating or when you're just developing a generative AI model, right? So think about it. When you have something, when you developing a generative AI model and you asking some question, say the question is gonna be, what are the different types of say, states available in India, right? If it's going to be a very normal question. So if the model has been already trained on the data, what we are trying to ask to it, then it can able to give you one correct answer. If I yes or no, yes, it's gonna be. Because if I say right, if the model has been already trained on the data, what I'm gonna ask to it, right? So if it has been trained on a Wikipedia data, which consists of all the states of India and consisting of all those things, then it might give me a correct answer. So there are these different types of states in India. For example, let's take another example. Let's take Singh. So if I just go back out of India, I'm just asking, can you just list out now the number of states, number of cities which is available in China? But unfortunately, the data has been not trained in, what I say, not trained in that particular model. So the model thinks, and finally gives me a very big question mark that yes, I cannot able to answer your question. Why? Because I don't have enough information to answer your question. So this is one case. Let's talk about another case, right? So now you have a label data, right? You want to classify or predict something. Okay, so you've been access to a public database which consists of a regression problem, which consists of a regression thing like predicting the weather for next 2 hours or 3 hours, etc. Stuff like that. So now, if you ask the same question to the same Gen AI model, what you have developed, that it will give you a correct answer. Yes, after the next set of 2 hours, the weather is going to be this, and you can expect rain, you can expect cloudy, you can expect sunny, etc. These things can able to happen. This one thing. Second thing is going to be, I'm going to give a set of data to it. Let's say I'm going to give a very complex set of data which doesn't have any kind of things, any kind of narration, any kind of labeling or stuff like that. So what happens is nothing but I'm just asking the model, Gen AI model, to find each and every important features available only inside it, so that try to take only the important features and remove all the unwanted features, right? So so that's going to be my example. Now my Gen AI model will think about it and think about it's an unlabeled data. So it will check whether I have been trained with unlabeled data, and it says yes, I've been trained with unlabeled data. And more sophisticated, the type of problem what I'm talking about, finding only the main important features and removing all the features which is not needed, is called as principal component analysis. So it finds yes, I need to perform a principal component analysis, and performs a principal component analysis and finds only the important features that is to be used. So here my model is performing both supervised learning and unsupervised learning, right? Both supervised learning and unsupervised learning. So that is called as semi-supervised learning. So when you talk about Gen AI models, all those things, Gen AI can able to do both supervised learning tasks and can able to perform unsupervised learning tasks, but only to a particular extent, right? It cannot able to perform everything. It can able to perform both those things at only to the particular extent. So that's the very important thing you guys want to know before entering into the attention solitude, right? So now I talked about the semi-supervised learning, which is a very important stuff you guys want to know, right? Now, deeping divert, right? The one important thing where the transformers have gained lot of attention is the attention is all you need paper. And if I'm not wrong, I just question all those participants. Hope you guys have. Did you see this paper already? Or if you don't, yes, that's good. Yeah. Okay, I got only one yes. Reminding all of you haven't seen what this that paper is all about. Two. Okay. Three. One no. Yes, I'll take that one no as a very important no, and I'll explain you what is all about. Even I do have the slides for that, so no issues. So attention is all you need is the base paper, which has been released from Google way back in 2017. And I would say 2017 is the year where we stepped into the world of transformers, right? Why? Because only in this paper, the researchers introduced the terminology or the concept called transformers. And if you guys might know or might not know, I'm not sure. Just have a look at the Google and Google or any kind of any kind of browser what you have. Just search about Lambda, right? Lambda is the first and foremost transformer-based language model for dialogue application. It's the abbreviation of Lambda. Lambda stands for Language Model for Dialogue Application, which was the first one developed by Google, right? Before ChatGPT, before OpenAI, before everything what we have, right? So I don't want to tell you the story behind Lambda, but you can just have a look at what Lambda has been doing and what Lambda did and why Lambda has been suspended. Right? So that's going to be an interesting read for you. So for that one, no, I just want to make sure that I just added this slide. So that next slide will be in terms of more focusing into it. So this is the one which is released in Automation is All You Need. And from this paper, a lot of other transformer architectures have been started. Right? So if you were aware about it, the first and foremost use case of transformer was translating your input text from one language to another language. Say if I'm talking, hey, hi, how about you, right? So I just want to translate from English to Spanish or English to French or English to any other language, right? So that's the main usage of transformer architecture. But you can able to ask a question because before transformer being which has been released, right? We do have a lot and lot of translation models, right? We could able to see a lot of things which has been involved. Why transformer has a lot and lot of what can I say importance when translations being a very important feature. These three things has been lot had made huge impact into it. One is the self-attention. Two is the multi-head attention. Three, it's going to be the positional encoding. I'll just give you a brief about it, right? And I'll also give you a link to a session what I have already took about transformers, and I'll also had so where in that session I'm adding one into video, right? So where I've included how the mathematical terms will work and how when your input is given to a model, how it has been transformed into a KQV vector, which is key query value vector, which is a very important thing. And moving back from what I say input embeddings to feed forward neural network back from encoder to a decoder, all those things will help. So I'll just give you a link of the video for that. So how this transformer architecture works, I'll just give you a brief about it. So say you have an input here. Say I'm just giving you a sentence for hi, hello, how are you? And that sentence will be converted back to an input embedding. As you guys might know, embedding is the function, embedding is a concept where it will convert your text format into a numerical things. So that numerical would be a positive or a negative, and it is in the form of floating point values. Why I just want to convert this into an embedding values, right? So when I give it back to self-attention or multi-head attention, I need attention to each and every word which has been tokenized from my input text. Say, hi, hello, how are you? I'm just giving a tokenization, word tokenization. So I've been tokenized with each and every word separated. Now I'm supposed to give an equal importance to each and every tokens which has been separated from my sentences. So that's why with the help of input embedding and the positional encoding, we could able to encode it based on the position which is where the particular tokens has been present into it, so that the encoder can able to encode each and every tokens more clear enough to it. So from there, we had an attention model over there. That's going to be a multi-head attention. So what multi-head attention is going to be, right? So talking more into it. So there are two types of attention. One is going to be self-attention, another one is multi-head attention. So both the things are not going to be different. Both the things are going to be same, but a simple architectural pattern is going to be changed from self-attention to a multi-head attention. So when I talk about my attention phases, right, as I said in the beginning, so when I split my sentence into different tokens, I have to pay more attention to the word which provides more meaning to the sentence, right? So let's talk about it. I'm just saying about This is a transformer architecture which was released by Google in 2017. This is a sentence, right? But the more important words here is transformer architecture, Google 2017. Why? Because I'm going to talk about the transformer architecture, and that was released by Google and which in the year 2017. Reminding else the words like the adjectives or the conjunctions what I've used in my sentence are not needed for the model. So we are supposed to pay more attention to the words or the tokens which is present inside the sentence so that it can able to pay more value when I'm converting from one language to another language. So that's is a major stuff why attention has been done. Moving back, even though we have an attention, moving back from attention, adding a normalization to it, then we move to a feed-forward neural network. So this is the encoder part. The left-hand side is an encoder part, and the right-hand side is the decoder part. From encoder, a decoder has been given into it, and finally we'll get the softmax, or as a linear layer with a softmax probability to make sure that how the probabilities of the output will be given to it. So I'm just giving just an overview about the transformer architecture, but I'll just push in a video about it. Just have a look and those how it works. Yes, so let's deep diver. So far we talked about how Gen AI model can be developed and how it is being developed so far, starting with the data which is being given to generative AI model, and as well as the base model which is being used for developing types of generative AI models, say encoder, decoder models. Now talking about how AWS having the generative AI stack and generative AI stack, right? They have three different types. So if you, I think so, you guys might have already seen this thing. So first we have the infrastructure for training the foundational models as well as for inferencing, where we do have GPUs with a lot of powers, with with a lot of powers, where we do have G4D and .2x large, ranging from 2x large to 18x largest, and we do have the type of AC2 instances that supports the performance of generative AI model when I deploy that, when I fine tune and deploy that into my thing. So where you have Trainium, Inferentia, everything. And moreover, we do have our very important AI here, which is SageMaker AI, where you can just use a SageMaker AI and just create your own notebook instance with the type of instance what you need. If you're going to work with fine-tuning your foundational model, you're supposed to have a GPU enabled into your SageMaker instance. And then moving back, you also have Jumpstart in SageMaker, where you can able to enable directly the generative AI models inside SageMaker itself. Then going back up, the tools which is used to build with foundational models. So we're going to talk more about this right now in this session, which is Amazon Bedrock. Why? Because SageMaker is a service which includes server into it, right? But Amazon Bedrock is a serverless, where one of the important thing where Amazon Bedrock gives a variety of large language models, the foundational models, where we can able to use it with just putting a modified access to the button and just providing our use cases for one of some of the models which is needed for it. And right now we have a lot of leverages which is available in Amazon Bedrock, starting with guardrails, starting with agents. Then we focus on prompt load, we have knowledge base, and we have prompt builder. Everything is available, and I can show you what are those things are available inside Amazon Bedrock and where you can work into it. And the applications, the Amazon queue. I'm working with Amazon queue now. Why? Because whenever I just write some code in my VS Code, I've enabled Amazon queue, where it can able to help me writing my code better, way faster. But I don't believe that. I haven't one more pitfall check to each and every code what I develop here, but it is more helpful for me, where I can able to develop much more faster, I don't want to develop almost 2 days, so I just don't want to sit for 2 days. Just with 2 to 3 hours, I can able to complete my full development stuff, So this is what I've said. So these are the broad choice of models which are available inside Amazon Bedrock, but this is somewhere I've taken a little long back. But right now there are a lot of other models which is also available, starting with a lot of other people, other companies also been providing models inside Amazon Bedrock, right? Starting with A1, 2, and Labs, where we have the Jurassic family of models, and Coher, we have command models, embed models, and we have Amazon, their own provider of models. We have Mistral AI, and we do have the Claude model, which is we also have meta models. We have Anthropic's Claude model, and if we do have the recent model, which is Claude 3.7 Sonnet, and we also have the image generation models, which is Stability.ai, and we also have Amazon Nova, which is one of the newest model from Amazon itself for generating images, right? So, and you also have DeepSeek R1 as well. DeepSeek R1 has been, you can also modify the access of DeepSeek R1. You can use the model ID inside your code to generate any kind of things inside with the help of DeepSeek R1 as well, right? So, yes, so I'm just gonna go for next set of things. One is RAG, right? You guys might have learned a lot about it, which is the retrieval augmented generation. But I think so. People might be knowing. People you might know retrieval augmented generation, and I think so. Students in AWS Cloud Club have seen Nefli. Nefli uses retrieval augmented generation for resume screening, and I think so. The students who are involved in Nefli 2.0 or the next 2.0 is also working with other use cases with the help of retrieval augmented generation as well. So I'm very happy to see that how the output is going to be, right? So what retrieval augmented generation is all about, but this is very old. Right now we have the agentic RAG. I'm going to show you how agentic RAG is going to work, right? And how my next steps is going to be, how where we're going to work on it. So, and we also going to have a very simplest, I'm just not going to run the code, but I have the code in my hand. I'll just show you the code, how I've developed into it, and so that it will give you an overview about it, right? So the first and foremost step, what retrieval augmented generation is all about. Well, because we have seen a lot of chatbots, which was very, let me say, the traditional way of creating a chatbot was very simplest, and it was like an if-else condition. If this particular question has been asked, the answer should be more sophisticated to this. Or else, if this question has been asked, so it's gonna be an if-else clause, right? So that the chatbot what is being developed is gonna be if-else clause. But we need more and more, right? We need more and more, and we want to make sure that the chatbot works in a way, right? It tries to take each and every nook and corner of the documentation what I give it to it, and I just don't want to write the if-else clause right now. But that's my major thing. I don't want to write the if-else clause right now. I need to overcome the if-else clause here. So that's where the retrieval augmented generation came. And as I already talked about, the vector embedding is one of the important things, right? So this is the conceptual flow of retrieval augmented generation. So I'll just walk you through some of the things. So first, you are supposed to load documents, whatever the documents you have. So we have a lot of things where you have documents in PDF, CSV, XLX, anything what you have. You can also have documents from your CRM analytics as well. Say you have a data document from, you have to what I say, point your document DB directly to the CRM analytics like Salesforce or Zoho CRM. Yes, it is possible where you can able to use with the help of API, right? But I'll just ask you a question right now. Yes. So one of the important thing which, what may say, discloses or replaces API call in terms of generative AI, which was very, what may say, familiar now, and a lot of things, a lot of people have started talking about it. Do you guys know what that is all about? What's the technology right now they're talking about? Any guesses? Which replaces API call when generative AI model is thinking, right? When let's say some example, I'm just giving you a question. Gen AI model wants to create, wants to make sure to take an API that takes, wanted to predict the weather, right? Just go for an API to a weather data and just gets the output. Now, it's not invocation, right? We do have another technology which has been rising right now. Any idea? Because when Claude 3.7 Sonnet was released, right? Claude 3.7 Sonnet people, the Anthropics team was introduced the same thing, but which was very old. But when they released this model with that particular terminology, it was very booming, right? A lot of other models are started to use that instead of using an API call. So, which is nothing but MCP, which is a model context protocol. So, with the help of model context protocol, we could able to replace API when generative AI model is thinking about the question what we have asked, right? The query what we have asked. So, which is very faster, which is very cost efficient. But because within Gen AI model itself, we are trying to develop it. We don't want to lend any API for that. So um, let me try to get the overview about MCP in the next consecutive sessions if I'm trying to host on it, and it will help you guys how it works. So let's get back to retrieval augmented generation. So that's the document what you're going to have. That's the database what you're going to have. So with the database, first and foremost thing, we need to chunk the whole document. We don't want to put the entire document inside our vector DB, right? So we need to chunk the whole document. So we use type of text splitters, which is available in Llama Index or Langchain, where we use character text splitter or recursive text splitter or a paragraph text splitter, or you can also build your own text splitter as well. It is possible to build it. Then moving out from chunking the whole document, then we need to create the embeddings. As I said, for each and every chunks for the entire document, we need to create an equivalent numerical number or a floating point number. So for that, we need to use an embedding model, right? You can also lend the embedding model from Amazon Bedrock itself. There are a lot of embedding models from Cohere or from Amazon itself. You have Amazon embedding model, right? But there are two embedding models in Amazon, which works only for English and which works for both multiple languages. So if you're working with a document which focuses only on English, you can use that model which is uses. Then once you have chunked the whole documents and you have made the embeddings breakdown, then you can store that into vector DB. And if I'm not wrong, if you do you guys know what are the types of vector DB which is available in AWS? Any idea about it? So what is the service that supports vector DB in AWS? What's the name of the service? Just I'm asking for the name of the service, right? Anyone knows what's the name of the service that supports vector DB? No? Or yes? Yes or no? Anything? No open search. Okay. It's open search. Okay, I can take yes, but I'm not sure to take the entire yes. Why? Because open search is not only the service which provides you the facility to store your vectors. Right. So this is one thing what I'm developing right now. Right. So you can store vectors in any type of vector DB, where you can store that in document DB, store in DynamoDB, store in even RDS, either with Aurora or PostgreSQL companion. You can store inside OpenSearch as well. So there are a lot of facilities, right? Not only OpenSearch, but OpenSearch was the first and foremost, which is used to store the vector DB, and OpenSearch is also serverless, right? To make sure that. But when I talk about RDS or RDS with Aurora or Aurora with PostgreSQL or PostgreSQL and other DBs, right? So we need to talk about that as service. So I have to store that in the vector DB, and once the user asks the input question, that input question will be turned out to an embedding, and it will be searched inside the vector DB. And with the help of the nearest embedding call, where we use the NN, right, the nearest neighbors. So where we call the nearest neighbors with the most relevant score, least relevant score. Sorry, with the high relevance score, with the least number of least distance between it, and we input map to the input query and give it to the LLM, and that LLM will generate the answer for you. So this is the more overall flow of retrieval augmented generation. This is the overall flow, but we do have a lot of advancement. But because if you guys might learn about CAG, CAG is a cache augmented generation, which is in which not right now, a month back or 2 months back was talked a lot about it, but right now it is being just shut down, right? Because people are not talking about it, right? So that is catchy. So which, as I just said, right, that the foundation models for rack system for Bedrock or for embeddings. And let me say, prefer to use, let me say, Amazon Bedrock embedding models itself. But try to have a look at the MTEB, the Massive Text Embeddings Benchmark. Let me share another slide if I'm not wrong. Yes, yes. So there is one thing called MTEB leaderboard from Hugging Face. So MTB leaderboard is the leaderboard which consists of the massive text embeddings benchmark leaderboard, which consists of the models which has been performed well in embeddings, right? You can use it directly from Hugging Face, or if you have an high-end GPU system, you can just download the best embedding models. Right now, Gemini embedding is right now it is being focused, and you can just go back to the model, which is the state-of-art embedding model, which is available here. Or some of the models is also available inside Hugging Face itself. Now you can be able to see from Link. The Link embedding Mistral is available directly inside inside Hugging Face. You can use it directly with the help of Sentence Transformer or with the Hugging Face API, or you can also download the files and versions available over here. But it's almost for 15 GB, not going to be big issues, right? You can just download it and you can use it. So that's, as I want to more precisely say to you, which is the massive text embedding benchmark for different languages, for the different use cases, what you're trying to build on. But still the question is more revolves in my mind, right? So if you guys might have heard about, right, there are two different things. One is the vector databases, another one is vector libraries. Do you guys know what's the difference between vector databases and vector libraries? Whether they both are same or both are different? Any idea about what vector libraries is all about? Why? Because so far we have talked about only vector databases, right? We haven't talked about vector libraries. So what is the difference between vector databases and vector libraries? Any idea about it? Any idea? Yes or no? No? Nope. Sorry, no. Library is not a collection of databases. No. Okay, so manipulate the vector DB. Nope. I'm sorry. I think so. You're talking about the Python library. I'm sorry. It's not the library which is used in Python. It is different concept, which is vector libraries. Right. So it's not a Python library. So okay. So I've written a blog post which was very long back, and I also published a video on it. I'll just share you that, and I'll share to the people who's hosting the session. Right. I'll just give it back to her so you can just have a look. It's very interesting when I just started to research about it, right? Why vector databases? Right? Why? Because the predecessor of vector database is vector library. From vector library, the vector databases has been evolved, right? So that was very huge, very interesting to read. So I'll just share you that as well. So this is the entire rack system, right? In the knowledge bases, what you can develop over here. So before going to the customization models, I just want you to have a look. So this is the Amazon Bedrock console, and inside Amazon Bedrock console, what I have talked so far, right? So you could able to see there are a lot of models, and I have granted for some of the models, but I have granted for some other models because I need to make sure that. So you could able to see there are a lot of varieties of model from A12 Labs, from Amazon, from Anthropic, from Core 6, from DeepSeek as well, from Meta, from Mistral, everything what we have. So you can request it and you can use it via your CLI or SDK. Why? Because I'm doing it right now. I'll just show you what that use case is as well. I'm developing right now, and I'll let you know how it is. What's the use cases. And as I said, right, I'll come back to agents when I talk about agents, and this is the knowledge base what I've developed. So as you can able to see, you can chat with the document directly here, right? You can just deploy a document. Like say you just choose the document. Say if I just want to choose a document and just put this one, and I can use it over here. So that is possible. I'm sorry. So that is possible here. That is possible here so that you can able to write. You don't want to write any single line of code to implement your rack system inside AWS. So just this one thing is also work for you, and you can also select the model what you like. So Anthropic's models are having a variety of things you can able to use it, right? So this is as I want to show to you now. And before going into fine tuning your large language models, I just want to show some things, which is the use case what I've already worked. I'll share you this repo as well. So this what I say repo consists of the Bedrock Llama 3, right? And this is gonna be a serverless event-driven architecture, right? So why? Because as I said, how translation of all those things works. This is one such example where we try to take the audio, the transcribe file, transcribe thing from an audio, then we need to put it back to the same S3 bucket, and we want to call the Amazon Bedrock to summarize the entire YouTube conversation, what both of them are talking about it. Right? So this works autonomously. So this is it's event driven. When you put something inside this and particular audio S3 bucket, this particular what we say Lambda function has been triggered with the help of S3 event notification, going back to transcribe, and the transcribe will transcribe the audio file and put it back to the same S3 bucket. Now it will have another Lambda function where that Lambda function also has been triggered with the help of S3 event notification, where the summarize transcribe has been Lambda function, and this Lambda function will now invoke the Amazon Bedrock. And you can use any kind of LLM, but at that time, Llama 3 was the one newest model which was released from Meta and was hosted inside Amazon Bedrock. And I've used that to summarize my entire conversation and put it back that same inside my same S3 bucket. So you could able to see the arrows are pointing to a same S3 bucket, and I've used two Lambda functions to raise it back, right? So this is one good example where you can use the Amazon Bedrock to to work on your use cases, what you're trying to develop. I'll just share you this as well, and I've written the Lambda code here itself, right? And everything is being done with the help of VS Code, right? I'm not done anything from the AWS console. I've done everything from here, and I pushed every Lambda code from this particular VS Code to the Amazon to my AWS console directly with the help of a lot of helping classes, right? I've written a lot of helping classes where it can able to push my Lambda function from VS Code directly to the AWS to my AWS account. So getting back, okay, if I'm not wrong, yes. So let's get back to this session, right? Yeah. So far we talked about it. So far we were working on the RAG, and we talked about how LLMs can be infused from Amazon Bedrock, how is it taking back how it will work in terms of semi-supervised learning. Then we talked about transformer architecture as well. But coming back, right? Yeah, whether we do have a possibility to customize our own models, right? Is there any possibility to customize my own model? Yes, it is. Where you can do with the help of three different things. One is all about RAG, what we already talked about, the retrieval augmented generation. Two is fine tuning, where you can fine tune your foundational model with the help of the data set what you have and continued pre-training, right? Why? Because the centralized one, that is continuous pre-training, is the technique which is being used by a lot of companies, lot of corporates now. Why? Because data is being iterated. Data right now, data in our world is going to be an iterative process, right? We could able to get new data by tomorrow, or by today, or by next minute, or by next second as well. We need to have a continued pre-training of models by putting each and every time lapse, or giving, say, for each and every month in a quarter, or 3 months in a quarter, 3 months in a particular year, I need to make my model to pre-train on the same data, on the different data which has been already generated. So this is possible. One thing, I'm going to show you a code example of fine-tuning right now, and I also shown you a code example of RAG. Continuous pre-training is this one, which is where we need to talk a lot about it. Why? Because each and every corporates will have their different way of continued pre-training of their own LLMs what they have developed. So there is a possibility to continue pre-train it, but it's more cost, right? It's not cost efficient, it's more cost, but we can do fine-tuning and we can do RAG for data what you have. This is all about fine-tuning your model. With the help of Oro 3 and with the help of Amazon Bedrock, you could able to see here I've used the Cohere model, the command line, and you could able to see I've created a model customization job. I'm sorry. I've used the model customization job. With the help of the model customization job, I've precisely mentioned that customization job is going to be a fine-tuning job. And I've also precisely put my particular, I'll just turn on my pen. I precisely put my data. What's going to be my input data? What's going to be my output data? And you could able to see both input and output are pointing to my SD bucket where SD path what I've been putting into it. And then I run my customization job. Yes, it is possible. You can able to fine tune the models, which is right now available. If you just go here and if you just see here, you could able to see lot of models available here. There is a possibility for you as well to fine tune the model on the data what you have as well. So with the help of this fine tuning shop, right? Because when I've seen a lot of things, right? So people use the model and just use it like this, but we need to make the model to understand our data. So one such good example is retrieval augmented generation. Second good example is fine tuning your model on the data what you have. So that we need to make sure that model to understand only on this data so that you're not able to provide you any kind of hallucination at the feature cases. So this I've already shown you, which is the Amazon Bedrock knowledge bases, where it is can support the native RAG. You don't want to create any kind of core. The knowledge base can able to provide you an entire surface for you to work on the retrieval augmented generation. Just upload your documents either from your computer or either from the SD bucket what you have created, and you can just chat with the data what you have and just ask some questions so that how it will work. So yes, the final part what I just want to more discuss here is agents, right? Agents is going to be one of the important things as of now, right? Because if you see in Amazon Bedrock, right, you could able to see a lot of builder tools that are available for you. One is the custom models, as I said, the fine tuning part, and right now the boom word right now which is available in the market is agents, right? Agents is the one which is being used a lot bit more people. Agentic AI agents are agentic blah 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 stuff like that. But what actually the agents is all about, and when I go much deeper into how agents can be invoked in Amazon, that's going to be the very important stuff where we need to know about it, right? So that's where we need to talk about it. So when you talk about agents, right, you are supposed to make sure to orchestrate the pattern how this particular agent is going to work, right? LLMs are just a supporting tool here, right? Rather than how you're going to orchestrate your agents is going to be the very important task for you, right? So let's take a simple example. So this is going to be a basic. I'm just sorry, you're a user supposed to be. So let's say I'm going to make an agent, right? So the agent's instruction is going to be, you are an agent that do these, that, etc. stuff type of instructions what I'm going to give to you. Okay, so what I can do as a user, I'm just going to say, do this for me, right? Only do these particular things, right? If I give you a document, just punch the document, just it, that's enough. If I give you a document, understand the document and just give only the summarizing thing. Don't give anything else extra. So we can create a number of agents, but the thing is all about, right? Whenever users interacts with the agent, we need to orchestrate the pattern where that pattern where focuses on which particular agent to be invoked for the particular query asked by the user. So that's the important thing where we need to talk about it, right? So with that thing, let's move deeper into how agents use the actions to get the work done. I've given you one simple example, right? So here there are two different type of actions here, right? So you do have one agent called as meeting assistant. And the instructions of the meeting assistant is going to be, you're going to summarize the meetings for me, and you're going to send the emails to the respective persons, to the respective persons who have attended the call. Right. So inside that agent, we do have two different types of action. One is going to be a meeting action. Another one is a utility action. Why? Because you're going to summarize the meeting here, right? You're going to summarize the meeting here and send the email. So first and foremost, the summarized meeting should done, and the send email stuff supposed to be done. So what happens? The meeting actions will take about. First, we need to list out all the meetings, get the action items, get the team members, and then followed by we need to send an email. So what happens? So first of all, the meeting action should supposed to work. After meeting actions gets completed, then we need to make sure to send it to an utility action. And that's what in the left hand side, the agent is also supposed doing here. So it takes the action items from the meeting, and if I just ask the user, can you just list the action items from my meeting? And the agent is gonna give you my answer. Here are the action items, say 1, 2, 3, 4, etc. Stuff like that. Now, with this action items which is being generated by the meeting assistant, just send them to my team. So what meeting assistant is gonna be saying? Emails in. And there is one important concept we are supposed to know. This is one particular conversation between the agent, and this is the second conversation within the agent. But as you guys might think about it, right? How this conversation is more correlated to this conversation. Why? Because I just say, let's send them to my team. I'm not saying what I'm supposed to send it, right? Do you know how this particular correlation happens between conversation 1 to conversation 2? For example, I'm just saying 2 conversations, but in case it will be lot and lot of conversations. How this is happening in terms of n number of conversations? Any idea about it? Any idea how the interrelation between the one conversation to another conversation is being captured by the agent? Any idea? Okay. Okay. So I request you guys to have a look, right? So why? Because it works with the memory buffer which is being created in between the conversation 1 to conversation 2 to entire conversation what we're going to talk about it. So say this is the one particular window where the conversation has been started. So once this window has been created, a conversation buffer memory will be created for each and every conversation. So now this conversation is being stored. Now, just now the query has been asked, send them to my team. The agent just identifies what that particular things to be sent back to the team members. So it will get all the team members out of it, finds, get the action items from this particular knowledge base and give it back, or from the memory buffer. I'm sorry, from the memory buffer, give it back to the get team and just give an email to all those people involved in the particular team. So this is how agents uses the action items, or what I say, the memory buffer which is being created. You're not able to create the memory buffers even in the retrieval augmented generation as well, right? With the help of LangChain, Llama Index, right? You can use the retrieval chain or retrieval memory chain with the help of LangChain libraries, and Llama Index as well has the facility to what they say, empower you with the memory buffer for each and every conversations what you make for the particular window, and you can be able to store that inside the buffer, right? So let's go to the next step. So how the agents can combine the actions and knowledge. So this is one where we're gonna talk about this as a last, right? So I've having one more slide for agentic RAG. So this is how it can able to connect with your knowledge bases. So where now it is very important that a lot of things to be taken care from the knowledge bases. For example, here we have created an HR policy assistant, and the instructions to HR policy assistants were, you are an HR agent helping employees to understand HR policies and manage vacation time. So we're going to have two things. One is the HR action, right? So HR actions is going to be request the vacations from the time from the employee's time. HR knowledge base. So why? Because you cannot able to simply request a vacation where the HR assistant should take a look of all the vacation policy which consists for the company, and you has to give it back to correctly, right? So let's take a quick look how it works. So I'm just gonna ask a question: how much vacation do I get per year? So when I ask this question, the HR policy assistant takes this question and gives it back to the knowledge base. And the knowledge base consists of the vacation policy for the particular employee and gives back this particular result. The previous use cases for more dealt in terms of actions only. We don't have any kind of documents or that supports the responses from the assistant or from the agents. But this time we are using a knowledge base. Now the next question. Cool. We just use as a full timer with 3 years tenure. You get 15 days. We get 15 days of holidays now. Now, cool. I would like to take it off December from December 8 to December 15. Now, the person is requesting a leave from December 8 to December 15. Now, with this question, the agent will understand that this question is supposed to go to the HR action. So, you could able to understand. Agents makes the decisions here. We are not making the decisions here. Agents makes the decision. With this question given to an agent, agents takes the right decision whether it's supposed to go to this particular action or whether it's supposed to go to this particular action or supposed to go to this particular knowledge base. So this is a very important feature about the agency. So when I ask this question, right, I would like to take an off from December 8 to December 15. So when I take an off from December 8 to December 15, this particular HR actions is being called and it will able to give you an output like this. So approved, enjoy. You have 8 more days available. But because from 8 to 15, we're gonna able to do so gonna be 9, 10, almost 7 days of holiday, right? Remaining we have another 8 more days. So from 8 to 15, right? From 8 to 15, so we're gonna back by 15. So we're gonna have okay. So we're gonna have taken 8 more days available for this period. So now we could able to see how how agents inside makes to combines their actions and knowledge bases. So this is one example for existing enterprise resources where the same thing like the HR agent where we could able to add one more knowledge base as well as the vacation actions, and we could able to add a lot of actions and lot of knowledge bases inside the existing enterprise resources. So cool. So that's pretty much the last one for me. A lot of agents which is being talked right now. So from RAG, now we have an agentic RAG. So from a normal traditional retrieval augmented generation, we have an agentic retrieval augmented generation workflow. Why? Because you could able to see there are not a lot of DBs which has been evolved. We do have a relational databases. We do have a vector databases. We do have a graph DB as well. My question is, what type of DB it's supposed to take? How can I able to make my system to understand for this particular question, this particular database should we take? The answer is going to be, I need to infuse an agent over here. So with the help of agents, with the question what you have asked, you could able to make the particular database will be selected and give it to the LLM and gives you an answer to it. Or else there is one more option for you as well. It doesn't work only with the person knowledge. It can also work with available functions where you can able to write tool function, LLM function, action functions, etc. stuff. That's what I said. We can able to work with REST APIs that can able to connect from agentic AI to back to the back to the particular functions what is available so far. So that is somewhat I'm working now. I'll just show you. Yes, I think so. Yeah, just give me a minute. I can share my screen one more time. Just give me a minute. Yes. So now I've started to develop this, right? So this is somewhat not a normal retrieval augmented generation, right? So as you guys might know, you can develop any kind of retrieval augmented generation very simply with the help of, let me say, models which is available in Amazon Bedrock. My intention of developing this is to work with lot of vector databases, starting with Chroma, Fires, they are vector stores, Chroma, Fires, which is available in Langchain, and start then going outside of box. We have to use VB8 and we have to use Pinecone DB. Then we have to extend our support to AWS, which consists of OpenSearch, DynamoDB, RDS with any kind of supports of DB. And my intention here is to make the traditional retrieval augmented generation to work for agentic, what I say, retrieval augmented generation. So I'm working on it with the help of LangGraph and with the help of Llama Index. So soon you could able to see this particular repo will be released inside my GitHub with the help where we'll be delving into two different cases, right? Three different types of cases. One, a particular retrieval augmented generation has been developed on different types of, what we say, vector databases. Point two, you can able to extend the simple retrieval augmented generation into an agentic retrieval augmented generation. Point three, you could able to judge the performance of each and every vector databases which has been created, starting from whether Chroma works well or Fires works well, whether Pinecone works well or VB8 works well, whether OpenSearch works well or DynamoDB works well, with the help of a platform called RagEval, where we're going to use the help of RagEval to evaluate each and every retrieval augmented generation what we're going to create. Not only that, I do have another plan, so I'll just show you what is going to be my next set of plans, and you can also have a look at that. My next set of plans, right? We're going to create the agents without AWS. That's my agent. So we're going to create without AWS, but with the help of Bedrock FMs, right, through AutoGens and through Crew.ai. So very interesting use cases I've started to develop with the help of AutoGens. Which one important thing is one of the important advanced use cases, virtual laboratories. I'll show you how virtual laboratories will look like in the particular use cases, how it can develop. So where you can give, I'm going to combine with the help of AutoGens and Crew.ai to work how to develop an entire team of members inside an organization. That helps an entire agents that can communicate with each other to provide you a best solution for the use case what you're going to develop. So that's going to be the next step. So I'll just show you that's the last thing, in where if you are not aware about, I've shown you the knowledge base, and this is how the agents will be created. I'll just where if you create an agent, you are supposed to give work with this. I already created an agent when I started working with this. So when you create an agent, you are supposed to, I just create an agent here. Let's wait for a while whether this gets created. And you're supposed to give the name of an agent where you can have a particular thing, and it will give you a model where you can also use another models which is available from Amazon, from Anthropics. I'm using the same model here, and right down, if you go more down into it, you could able to find two different things. One is action groups, another one is knowledge base. So far, what I said, you can create only the action groups, right? That's not going to be the big issue, but you can also have the facility to add a knowledge base over here. Guardrail is one for security purposes, and when you create action groups, there are two important things where you can able to work on. One, you can able to create the action group with the help of the function, where the function is going to be a Lambda function. You are supposed to write a Lambda function with a set of codes, or you can also define with an API schemas as well, right? With where the API schema, which is available directly inside your S3 bucket, or you can also provide a simple line of code where from that code you can able to develop to the next level, right? So this is how we can able to create an action group for it. But for creating action groups, you're supposed to wait for a while, and that Lambda function is supposed to be written over there to write that particular function to implement for each and every test cause what you're going to make for it. So to be more, then getting into knowledge bases, right? So when I go deeper, just give me a minute. Yeah. So if I just have a knowledge base, right? I'm just going to give it a hit and just go down into it. I can also add a knowledge base. Just you can add a knowledge base, select the knowledge base which is being created over here. I've already have a knowledge base demo. You can create a knowledge base which works with one particular document, and you can also add the document or add the knowledge base over over here as well. So there is an option here without writing a code with the help of AWS console itself. You can just map it to AWS Bedrock agents. But I don't want to work with them. Let me say it is easy for you to guys to start with Bedrock agents. But let's start writing the code in AWS code. That's my next step as well. We're gonna work with the serverless agentic workflows and serverless agentic RAG with the help of Amazon Bedrock and Amazon agents, right? And I want to show you the last thing where the data automation process, but because this is very new, which is released in Amazon Bedrock, where you can able to make sure to use the RAG indexing concept or intelligent document processing or media analysis concepts, where you can able to use the automation process over here, right? So you can just go for the demo, or and you can just I'll just click this particular bank statement, and this bank statement supposed to, it is an image format. Actually, it is an image format, and I want to make sure to extract the results out from the bank statement. You could able to see this is the bank statement, which was you could able to see a little down, and you can able to see this is the text with the market down. And if you go more into the element level, this is the figure which consists of this particular thing, and checking and saving CDS. And so it just is in convolutional neural network, right? But with the help of image generation models or image models, which is available inside Image FMs, which is available inside Amazon Bedrock, we are trying to use this data automation part. Okay, so yes, so that's it from my side, and I just close my slides as of now, and I just open for any questions if you want to ask to me, right? Any questions? Any questions as of now? Okay, so MCPs are nothing but the model context protocols. If I just walk you through the agentic RAG, right? When I talked about agentic retrieval augmented generation, there are a lot of tool uses we can able to use it, right? Tool can be an API, a REST API that can be called outside of the development. What you can do, which can able to take some data, but that is gonna be more cost, right? You have to pay for the API. If it is going to be a free API, it's going to be very much useful for us. But if it is going to be in cost for the API, then it is going to be very difficult for us. But rather than API calls, right, we could able to make our LLMs to understand the data which is outside which has been trained on it with the help of multi-context protocols, right? So soon I'll also release something on model context protocols, which will help you to drag you down how it will work and how can you able to integrate that in your code as well, right? Anything else? Thank you. Anything else out of the box? If you want to open your mic and want to ask some questions, I will be happy to answer. Anyone? Anything else needed from my side? Okay, then. So if you don't have any other questions, I'll just post my LinkedIn ID where you can connect with me on LinkedIn. And if you have any doubts regarding whatever we have seen so far, and you can also, let me say, text me if you want me to. Let me just do that. Yes. So. Yeah, so that's my LinkedIn ID where you can use my LinkedIn ID, you can connect with me. I'll post some what do you say, new things which has been released in the market right now. So in the Gen AI world, the Gen AI market, new models, new concepts, new techniques, and whatever I do. So that will be helpful for me as well as helpful for you, people who are trying to see that, and I can also get some comments, right? So with that comments, I can improve what I'm right now I'm developing, right? So yes, so let's wrap it. Mona, are you there?
Yes, yes,
Yeah.
Rahul. Thank you so much. Now we'll come to the thank you note. The thank you note will be given by Namrata Chowdhury. Namrata, you can go.
Yes, Arka. Good evening, everyone. As we approach to this insightful and enriching session, it's my honor to extend a heartfelt word of thanks on behalf of AWS Cloud Club St. Joseph's Institute of Technology. This event would not have been possible without the support and contribution of many individuals and teams, and I would like to take a moment to express our gratitude. First and foremost, I would like to thank Mr. Rahul Opal for his time, knowledge, and the valuable insights today. Thank you, sir. Your presentations have given us much to reflect upon and undoubtedly inspired us to push the boundaries of innovation. A big thank you to all our community members for their continuous support and our cloud captain Mohana Priya for their tireless efforts in organizing this event and ensuring that everything went smoothly. Finally, I would like to thank all the participants for your active involvement, engaging questions, and enthusiasm throughout the event. Your presence has made this event truly special. Let's continue to build on the knowledge we have gained and work towards a brighter and a more innovative future. Thank you all once again, and we look forward to see you again at our future events. Thank you.
Thank you, everyone. Thank you, guys. Thank you so much.
Yeah, I request all the participants to stay back for a minute. Thank you, Rahul Gopal, for joining us for this beautiful session. And truly, your expertise and insights will definitely help them to move forward.